Welcome back to this set of videos. My name is Revi, and in this video, I'll be discussing how to find the equilibrium relative price. So in an Edgeworth box scenario, one of your main tasks is to find the equilibrium price. And the way I would like to organize this video is to first talk a little bit about the key ideas, key concepts. So in the previous video, we talked about how if I randomly picked some initial endowments and I randomly picked two prices, I could check whether that price for those initial endowment could be an equilibrium. In other words, that the markets would clear, okay? And in this video, I would like to go over how to actually find that relative price. And the key ideas that we'll be discussing, or key concepts, is this idea of relative price. If you remember from the previous video, if you remember, I showed you, for example, here, how if you have two different prices, I think it was here, right? So if we had two different prices, either price of 2 and 4 or 4 and 8, the budget constraint look the same, identically. And therefore, what we really care about is the relative price. So px over py is a half in both of these situations. And we'll see that that will simplify our problem, because from having two unknown variables, our job will be easier and would be to find one unknown variable, which is the ratio of prices. And the second thing is we want market clearing. Remember what makes a set of initial endowment, a pair of prices, or a relative price, and some final outcome on equilibrium is that the market clears. And we're going to rely on Walras law to speed up our work. So we only have to check one of the markets. Remember, we have two markets, the good X market and the good Y market. So I'm going to take a problem from before. So here's my Edgeworth box. I have two individuals, Revi and Ben. They're looking at food or shelter, food on the x-axis, shelter in the y-axis. There is 14 units of food and 10 units of shelter. Okay, and the endowment for Revi is 3 of x and 5 of y, and endowment for Ben is 11 and 5 respectively. They have identical utility functions. Okay, they both would like to effectively spend half of their income on good X and half of their income on good Y. Okay, so from here, I would like to go about solving for this particular economy to find the equilibrium price. Here's how we do it. Walras law tells us that we can focus all our attention in one of the two goods market. So I'm just going to focus on X. And I'm going to say, what is the optimal demand of Revi for X as a function of the relative price? So to do that, I'm going to make an extra assumption, and I'm going to say that the price of X, I'm going to define it as just P, and the price of Y, I'm going to set it as 1, as the numeraire. Because by adjusting the price of X, I effectively will change the Px over Py variable, which is all that I care about. Because in this world, we don't have money, we have endowments, we have units of X and Y, and therefore the actual prices do not matter as long as the ratios are the same. And therefore, I'll be able to say, well, this is a Cobb-Douglas. I go back to my Cobb-Douglas video, so I'll be able to say that this is half of the value of my endowment, where I have 3 X's and 5 Y's, I'll spend on X. So I divide this by P. What about Ben? What does Ben do? Well, Ben does the same. He will spend half of his endowment, or half of the monetary value of his endowment. What did we say he has? He has 11 times P plus 5 times 1. He will spend that on X. So we'll divide this by P. Okay. And this will be the optimal demands for Revi and Ben for an infinitely possible amounts of prices. So this would be, I could pick the P to be equal to a half, which is what I did in the previous, video, right? And if I pick those prices to be the half, I could find what X star is and what X star R is and what X star B is. But what makes it an equilibrium? Well, the condition is that the market for X must clear, which means that the demand that Revi has plus the demand that Ben has must sum up to the total of 14 X's. If it's more or if it's less, the market does not clear. because demand does not equal the supply. So then my job becomes quite simple, is to add these two demands and set them equal to, and set them equal to 14. And I'll find a price, and that price will give me what I'm looking for. And therefore, let's do that. Duplicate this plus this will equal to 14. Multiply everything by 2p, we'll have 3p plus 5 plus 11p plus 5 times 1, not 51, is equal to 2 times 14 times p, or 28p. And this is a simple single variable problem, so you should easily be able to solve this. So we have 14p plus 10 is equal to 28p. 10 is equal to 14p. P is equal to 10 over 14, or 5 over 7. That was not a nice number. I made up that utility function. I made up those endowments on the spot, and therefore it didn't have to be a nice number. Okay? But this 5 over 7, so if the price of X is 5 over 7 and the price of Y is 1, would clear the market. And you can plug back this price into this to find out the equilibrium allocation. You could then plug in that price into the demands of Revi for Y, which again is going to be half of the value of the endowment divided by the price of Y, which is 1. And the demand of Y for Ben is going to be a half, 11 times P plus 5 divided by 1. Why divided by 1? Because we set the price of 1 to be equal to the numeraire. Okay. Now, as a little checking point, if you like, I could repeat this exercise. But I could go and say, well, the setting Y as the numeraire wasn't just an arbitrary choice. Maybe I'm better off if I just set X to equal to 1 and price of Y to equal to P. Sure, we could do that. We just need to change this optimal X and Y, and in fact, let's redo that. And of course, if I do that, what I expect to find for the price of Y should be the opposite of this, the inverse of this, so 7 over 5, right? So let's do that. So let me just copy paste. Let me paste these things here. This was the demand when I set the price of X to P. Now the price of X is 1. So this is actually a bit nicer perhaps because I'm not dividing by P. And now X is 1. I'll delete the P here, but Y is P. So this will be 5P, 5P. This P here will disappear. And again, the equilibrium condition does not change. I would like to add the demand for X with basically the two demands for X and set it equal to my usual 14. Multiplied by 2, I have 3 plus 5P plus 11 plus 5P is equal to 28. I have 10P is equal to 28 minus 14. I have P is equal to 14 over 10, or 7 over 5, exactly as we predicted, right? And this would be kind of a nice way to check our work. We don't have to do it this way. But there we have it. We have a little milestone in this little series of lectures that I'm doing. We started off with utility functions that seemed like they were sort of isolated questions, where prices were taken for granted, right, were given to us, to a situations where we can still use the same tools to find an equilibrium price or a market clearing price. Effectively, we've used a very simple model to mimic an economy which has two goods, to have some starting position of that economy, and to make predictions about where this economy will go. How will these people trade? What will be the prices, the relative prices that these two goods will trade? And that's a very, that's a model in itself, and a very wonderful model. And what we've made progress on, even though in a very abstract setting, it's quite remarkable. Thanks for joining. I'll see you on the next one.